Good morning once again to all. As told by Dr. Balwinder, that some portion of regression or training part has been covered. So, I would try to correlate directly, like correlate the machine learning and neural network and deep neural network rather than jumping directly to deep learning, because my understanding was that the course is on the deep learning, so I have to give more focus on deep learning anyways. So I shall try to have a bridge kind of thing. Okay, so first I would like to just give me a second. Right, my screen is visible. Okay, yeah. First I would just like to know from the participants, can you recognize these pictures? Anyone from the audience?
Ma'am, Gandhi ji,
Okay, this is Gandhi ji. This is
Mahatma
okay.
Gandhi, and
What about this picture?
this is also Gandhi ji picture because uh,
And this picture?
mm, uh, this I can't recognize this.
Anybody? Okay, Mahatma Gandhi is okay. Good. The first two pictures,
Ma'am, I think first one is cave painting from Ajanta,
right? Good.
and the second one is our parliament.
Very right. So, chaliye. I'm glad. So, what I want to represent from this slide is that how did our brain recognized these pictures? There was no name mentioned in it. We are not living in these, or we are not, I'm not staying in the Parliament of India daily. We are not seeing Ajanta Ellora and Mahatma Gandhi. Okay, we see, but this picture, this is not anybody. Any person can be bald and he can use a circular specs, but still our brain can recognize that this is Mahatma Gandhi, right? Why? Because now if I say, because we are able, our eyes or our brain is able to capture certain features very prominent to these pictures. So if Mahatma Gandhi is okay, we see so many because our brain is seeing this picture from since birth and on all the uh, you know uh, the notes or everywhere it is showing. Just give me a second. So this is the like, because we can, our brain has been trained or it has learned from various experiences that this image, which has, it is circular in nature and these pillars are there and this is the ground, or like terrace, this garden is there. So our brain is able to extract certain information, certain prominent features from these images and take a decision and remember or retrieve that information that this is Parliament of India, right? So these two lines, if you see this, these two lines, they are nothing very specific or very special, but because our brain has been trained by seeing this particular the bald and the specs, that we are able to find out, right? So this intelligence portion or the brain capability of recognizing the pictures, recognizing the events, recognizing the faces on the basis of certain prominent features gives us an edge of the intelligence over the machines. If I ask any computer to recognize this, until and unless I do not specify in the algorithm or I do not give its program that this should be round in nature, these many pillars, this color, this gate, dimension of this gate, then only machine will be able to recognize that this is the picture of the parliament. Means we have to dictate the terms or we have to give the input to the machine. So what is required from today's like for the when we talk about the era of artificial intelligence, basically we want that our machines should be made learned in such a way that they are able to achieve the intelligence which our human brains possess. So intelligence of not only taking the information, that machine is also taking the information, but for processing that information, for recognizing the features, for understanding that information, for taking the decision, in fact. So, decision is to be taken by the machine intelligently as our brain takes the decision. So that is the field of the machine learning, that as the name suggests, we are making the machine learn, right? So there are so how does a machine is going to learn, or how we are going to make the machine learn? So as we human beings, what is, because machine learning or artificial intelligence is basically it is a model to replicate the human intelligence, how our brain is working, how our brain is extracting the input from the external environment, how our brain is taking that input from the environment and using so many other things to come up with a decision, right? So similar way, we also expect that machines should learn from experience. We are learning from the experience. This Mahatma Gandhi image, our brain, on I think only once or twice, our every parent tell the student or the child that this is Mahatma Gandhi. And because we are, every time while growing, we see the picture of Mahatma Gandhi so frequently everywhere, then every year on 2nd October, on every, now it's not on the notes currencies, but otherwise it was on currencies. So our brain keeps on learning when the Mahatma Gandhi was bald or without specs or with mustache, then also our brain can take the decision and can remember that this is picture of Mahatma Gandhi, because our brain has learned from various stages, by experience it has learned. So similar way, we really wish that our machine should also learn from experience. It should not learn from only the step of instructions which we are giving to the machine. Okay, if we give this instruction, then only machine will process that information and give the output जो अभी तक होता आया है. But now in this artificial intelligence, we want that our machine should have the capability to learn without being explicitly programmed, right? So this is the main aim of the machine learning, which you have like done in the regression part also. So uh, just to brush up the things, what we do is, in the machine learning, we take certain data can be inputs, features, as I told you, like this picture, if I say, so if I want to make the machine learn, so how our brain is learning, that we are able to see certain features, the shape features, the number of columns, the gate, the position of the gate, the stones, right? So these are some explicit features which our brain is taking and formulating the information and taking the decision. So similarly, we also have the data which we say, which is given to the machine learning algorithm, which is used to train the machines, right? That is certain features which will be termed as the training set or the training data that is given to the machine, so that machine gets that information about the exclusive features, prominent features, and machine gets learned, right? I'm not going into the details of how we are learning and how we are doing that. That is the basic part of the neural network models or neural network learning. So machine gets learned, and we call that model as the learned model, right? Its weights are adjusted, the input is given, weights are adjusted, learning models are employed, okay? Back propagation error, whatsoever is there, we do, and we say that model is learned. So that whenever now unknown data, any data which is unknown, like my brain learned about this picture of uh, this Ajanta caves. I saw this picture again and again. But if some similar type of picture comes as an input to the machine, then when that machine, that input is given to this learned model, this model should be efficient enough, should be capable enough to predict that this picture is from the Ajanta Ellora caves. Then only I can say that my machine or this model, computational model, basically when I am saying the machine or the computer, so basically inside it, it is a computational model, mathematical model, which is taking the input as the data, which is not being used for the training, and it is capable to do the prediction, right? So this is the basic algorithm which I think everybody can understand. So we have different type of problems which can be solved by the machine learning, like classification. If I have different inputs and I have to classify in the two classes, simply if I take the example of biomedical image, if I have a, say, picture of a cancerous tissue and a non-cancerous, or benign or malign, so I can use the machine learning algorithm which can assist the doctors or radiologists to come up with a algorithm which can classify the input into two different classes. That classes can be anything. I'm taking the example of the medical images. It can be differentiation between an apple and an orange, right? Differentiation between any two classes. Similarly, regression, which you had already had a session, that you can predict the future values based upon the previous values. Then you have anomaly detection, right? And again clustering, that is the you can cluster, or you can form the groups of the inputs based on certain similarity features. So this is one of the, these are some of the applications of the machine learning prominently, which can be used for any application, whether for image classification, for radar and satellite images, for clustering, right? Or GIS, or for anomaly detection, can be signal, audio, video. So a lot of communication problems. So very many applications are there for the machine learning, where all these applications can be done. Now I want to generalize this thing, if it is clear. So basically, what machine learning is doing is, whatever input we are giving, we are finding out certain features which are handcrafted features. Means, if I want to, say, define whether I want to train a machine on the basis of that, to classify whether this is a car or this is a truck, right? Or a jeep. So what we are going to do is, we are going to find out the some of the features which are prominent to this car, and similarly some features which will be prominent to truck, some features which will be prominent to, say, bicycle or whatsoever, right? So some handcrafted features are to be extracted, and that is to be given to a classifier, right? The same thing which I have told you. So these features, we can come up with the like shape features. When I say, okay, if some of you do not have that understanding, so features, if I say, that may be shape features, that what is the what is the size, whether it is rectangle, whether it is the shape of the windows, what is the size of the wheels. So these are the shape features. Then you have statistical features, what is the area, perimeter, right? Then you have texture features, then you have wavelet features. So there is n number of features which are available, which can be used based upon the application which we are working on, right? So we find out the handcrafted features and give it to the classifier, or give it to the machine, which is trainable, right? So main thing which lies, like example is like this handwriting recognition, or biometric, which we all have nowadays, face recognition, or finger point biometric recognition, or handwriting recognition. These are few applications where we are prominently using the machine learning. So now, when, say, suppose I want to see whether it is 2 or it is 3, and it is to be given, machine gives that it is 2, right? So basically what is happening is, we are dividing this input into features, into a vector, right? So if it is a 16 cross 16 image, so we have 256 pixels information, and I divided this into one vector of 256 elements from x1 to x256, right? And the presence of whether this pixel, what is the whether it is colored or not colored, right? So based on this, one feature is of the first element, so no color. Then second will be second feature, third will be, and so on. So there will be some elements, some pixels which we have color in it, like this portion, and rest of them are not colored, right? So there is ink or there is no ink. When this input is given to the machine, the output can be from 1 to 10, that is 0 to 9 basically, because 9 values can be there. So each dimension will represent that whether it is a ink or no ink, and depending upon this, machine will be trained, and you will get the output whether it is 1 or it is 2 or it is 3 or it is 0, right? So what I want to say is everything is based on these features, that how these, which features are extracted, how these features are extracted, and which features are prominent features to give us the result properly, right? So if I take this example, so this was given to the classifier machine, and it was seeing the output maximum was zero point 0.7, which is corresponding to number 2. So the machine will give us the result that this image belongs to, or this image is 2. Okay, so this is how the handwriting recognition goes on. Okay, so this is the one simplest example which I have taken. So if I, then how do we employ this? We employ using the neural networks. So neural networks, you might all be knowing about it. So highly structured networks, we have the input layer which takes the input, that may be set of the features, again the same thing, and these inputs are passed on to the various processing elements, which are similar to the neurons of the human brain, and after getting processed, passing through the activation function, to the bias, all the mathematical modeling being done, the output of each neuron of this layer is moved to the other layer, and this goes on till the output layer. This output layer is the layer which is responsible for giving us the output, right? So this is the basic crux of the neural network. So you see this. Okay, I won't go into this. Now, when we are talking about the machine learning and neural networks, so why do we want to go to deep learning? Why were we not satisfied with the performance of the machine learning, or what were the challenges, in fact, which we were facing with the machine learning, that we moved towards the deep learning? If you see now, every topic or everywhere we talk about the artificial intelligence with deep learning in communication, deep learning in signal processing, deep learning in image processing, you name any domain, and the application of deep learning is there. So now I would just like to introduce first that why we move towards deep learning and what is the difference, how the deep learning becomes more effective as compared to the neural learning or machine learning, right? Now, if you can see this, friends, so in machine learning, what I have been talking in my previous slides, that we are taking an input, and here is the person who is responsible to extract the features, right? So that these features, which features, as I told you, shape features, color features, texture features, any type of features, this person is going to find out that which features are the prominent features which can specify or justify that the input given to the machine is a car. Once these features are extracted, they are given to the trained machine, right? And it will classify that whether it is a car or it is not a car. This I have been talking again and again, right? Now, so it means the performance of this model will depend upon what type of features have been given by this person, whether these features are sufficient enough. Maybe features may, if I suppose, now it will become so much subjective. If I am working on this, right, then I may come up, say, with 10 features, that 10 features are sufficient and prominent to classify this input as a car. Suppose somebody else, like Mr. Sudhir Singh is working, he is more experienced, he will say no, 6 features are sufficient, rest 4 features are not prominent, they are redundant. Some novice person, say another person, say Pooja Prashar, she may be, she is learning, she will say no, 20 features are required, right? So this feature extraction is very subjective, and it becomes dependent upon the person who is working on it, and the output of this is depend, or the performance of this is dependent upon these features. So if this is not done properly, their number of, because number of features means more complexity, more processing, right? So it becomes the performance of the machine learning algorithms becomes dependent upon the feature extraction algorithms, type of features, number of features, right? So the classification is based on this, right? So what I was talking about is that this so the main subjectivity is because of this person. So it was take and challenges were faced because of this concept. So it was seen that to remove the subjectivity, what if we remove this person from between, right? So that if we do not have this person in between, the subjectivity is removed. But we obviously we need to have the feature restriction. So that can be done by the machine itself. That is what the machine was learning to classify. Now the machine can by itself learn to classify as well as to extract the features. So that is the major difference conceptually between the machine learning and the deep learning. That is what type of features, which features, how many features, right? Prominent features, redundant features, all these decisions are to be taken by the machine itself, so that any person who may be novice to the machine learning, who may be experienced, who may be very much experienced, it will remain independent. So that is the main concept of the uh, this problem. Now, earlier it was seen that when we are extracting the features, so basically features are in the form of a vector. As I showed you that even if that was an image where 2 was written, this we were not taking as a two dimensional image, but we were converting this two dimensional image into one dimensional set of feature vectors, right? So if I'm giving this input as the car, then this input is a two dimensional picture, but it is converted into one dimensional by specifying the features. Now, when this deep learning is being used, then it means the image has to be uh, just image. When we have to work upon the image, it means we are working on two dimensional data, not on the one dimensional data. So where the problem will be, friends? So we were talking about what if the input is an image. So earlier we were having that, as I told you, that the image, the two-dimensional data was converted into one-dimensional as the feature vector, right? And it was given to the neural networks, the hidden layer, the processing was done and the output was taken. Now, if you see the number of parameters, if say this is 400 cross 400 cross 3 input image, if you see how we divide each pixel, see, so each pixel is 48,000, okay? And 40, when we are having colored picture, so RBG, all the components are to be there. So it means 48,000, 48,000, 48,000 plus one bias. So you have 230 billion of input features which are to be given to the network, right? So it means every neuron, and it is a fully connected neuron, so every processing element has to process this much of information to give me one single output, right? So lot of computation processing time will be more, efficiency may be less, and complexity will be very very large, right? So this was taken as, so like this it was, so it was very tedious, first of all very tedious and very difficult to develop handcrafted features. Now if you want to find out this image, to give the output of this image, so we know tiger, but you just see that how difficult it is to find out the features for this, that handcrafted features. So this was the main problem. So with the deep learning now, because the machine itself is learning from the images, so the layers of the deep learning were responsible to extract certain features. In the beginning, we call them as low level features, where you can see that only edges or sharp edges or variation in color was there, right? In human brain also, whenever you see a picture or visualize a picture, it's always the main focus first goes on the edges. Like ye picture bhi if you will see, so the main focus will be like the transition, this eyes, the tongue, this portion. Our human brain is also designed like this. So low level features are first calculated, then this information is moved to the higher layers, and then some more features, some other useful information which we call them as mid level features, right? And then further it goes on till it moves to the more levels, and we come to the high level features where you can see that some images of eyes, nose or variation is there, right? So when we talk about the two-dimensional image where the high dimensional vector is there and we do not have feature vectors, then we move from a regular network to the deep neural network, or we say the first main deep neural network, that is the convolutional neural network. So converting the input images into feature vectors loses the spatial neighborhoodness, first of all. So if I say that I am converting this into vector, the eye is a vector, eye is a feature, but what is the position of the eye, that loses the its relevance. Are you getting my point? So I, this portion may be one feature, but whether it is located here or it is located here, right, or it is located here, it can be. So main thing is that the locational information is lost because of conversion of two dimension. It can be here also, it can be here also. So the spatial location is lost when we are converting the images into the feature vectors, and the complexity increases to cubics, as I showed you that 400 cross 400 image or simply 256 cross 256 will also result in thousands or millions. So to address this problem and to reduce the number of parameters and adapt the network architecture, the convolutional neural network, that is the main prominent network of the deep neural network, was introduced, which is a class of deep, and it is feed forward artificial neural network which were primarily used for the visual images. Now it is being used for the signals also, right? So images problem, that is when working with the two dimensional, uh, was covered with this convolutional neural networks. Now I'll be giving more focus upon the convolutional neural networks. So now if you see this, first of all I'll show you, like if this was one image, if I had to, and this is image of Einstein, and we had to recognize or predict this image by a normal neural network. So what we were doing, that every pixel was taken as the information, right? You were taking the information from each pixel. You can see this. So every neuron in the neural network was given all these information. So if it is 256 cross 256, so every input will be given to the as the input to the neuron, right, like this. But so number of features, number of the parameters will be more. In case of convolution neural networks, we divide this into simple kernels, or we call it as filter. Okay, forget about kernels, we use simple filters, so as we used to do in the signal processing. So every filter will process the information related to certain portion only, right? So it means what the locational the spatial locational problem which was occurring in the neural network is covered by considering these kernels or these filters. Now taking an example, I'll show you how. So if I have a 200 cross 200 image, if it was simple neural network, we had 1.6 billion parameters which were needed to be processed. Whereas if I take a filter or a kernel, say of size 5 cross 5, right, and I find out 100 features, then it means only 2500 parameters. So you can see the variation. Same image, how it is being used or how it is being, you know, processed, that how so much less number of parameters are there, which reduces the computational complexity. How it happens, I'll come to this. So convolution neural network is a fully connected structure, right, and which takes that the inputs are images, it reduces the amount of parameters, and it encodes certain properties into the architecture. I'll come to this. First, I'll just give you the flare of that how does a sample architecture of the convolution neural network looks like, right? So now as you see this, the input is an image, right? And these are the various layers, these are the various layers which are responsible for first portion which I am talking about again and again, that is the feature learning, right? Because we were of the viewpoint that earlier our machine learning was only responsible for this classification part, but with the deep learning we required that we should have some model which could find out the features. So these are the layers, we call them as the convolutional layer, pooling layer, and we have the activation function as the ReLU layer. So this is a sample architecture which I'll be discussing. So now if you see this, um, so first, like when the input goes to the first layer, these layers are now responsible to give me the low level features which I have shown you in the previous slides. So low level features, only the edges, you see different colors, contrast, slanted edges, sharp edges, straight, horizontal, vertical, only edges go like this, right? Then this information move toward from convolution, ReLU, max pooling to the other layer, and the output of the second set of layers give you the texture information, certain more prominent features. And then passing through these various layers, it gives you again, now see, the different objects parts can be seen. And finally, when it goes into the classifier, this network will be able to classify whether it is a hen or it is a yacht or a table or anything, right? So main thing is that this portion which was subjective in nature in neural networks is covered by the machine itself and removes the subjectivity. This is the main aim of the convolution layer. So now one more thing I would like to specify here, that here we talk about three main prominent, because we are talking about the image, so it means we have to take care of the width of the image, height, and the depth, that is the dimension which we are working on, because in neural network we are working on only one dimension, right? Even if it was a two-dimensional image, it was converted into one dimensional based on the features, and then it was shifted and moved. Whereas when we are working in this convolution, we have to take care of what is the, because it is two-dimensional, what is the size of the image in terms of not only height and width but also depth, because if it is a colored image then we have to go for the RBG, the all the three slides, right? So prominently there are three stages of convolution layer. One is you have the first stage is convolutional stage. Second stage is to cover up the non-linearity, because all the complex problems or the real world problems which the deep neural network has to solve are non-linear in nature. So that problem has to be taken care of. And the third layer is the pooling layer. So these are the three prominent layers which form one stack of layer in the deep neural networks, or CNN I would say now. So this can be like input, convolution layer, nonlinearity, and pooling layer to the next layer. So this is one layer, but there can be combination of these layers also. So it is not necessary that only one set is there, but it can be repetition of the next sets. So every layer has particular function to be performed. So convolution is a layer which is a feature detector basically, and it automatically learns to filter out, because we are using the filters, we are using the kernels, and I hope everybody of you know about the importance and the functioning of the filters, right? So the convolution layer is responsible for detecting the features by filtering out the needed information using the kernels. Then the pooling layers are basic. Pooling layer is basically, you can think of that it is the data reduction layer. Earlier, which we used to dimension for the not data reduction, in fact, dimensionality reduction. Earlier, we used to have PCA, ICA for dimensionality reduction. In the CNN, we use the pooling layers as the layer for the, because we're starting with so much of data, so much of information, right? Thousands. One more thing I want to bring into notice is, because there is tremendous amount of data, right? The data is growing, whether it is medical images, whether it is weather forecast, uh, the the satellite images, the robotics images, any data, it is growing with the digitalization. So much of, there is explosion of data. So when that data is to be used for the neural network, it becomes very difficult. It becomes very the efficiency of the neural network is compromised. So deep neural network is very good for dealing with large amount of data. So when we are saying, say we have 2000 pictures, we have 3000 pictures, our training will be good. Network will be able to learn very quickly because it will have the so much of information in its training data, but the processing speed and the processing power will be less, right? So when we are starting with large data, say 2000 images, and every image of 256 cross 256, so you can think of so much of information. So dimensionality reduction plays a very important role. For that, pooling layers are responsible. We'll see how. And the third one is, last one is the fully connected, which is responsible for the classification or the recognition part, right? So if you see this, any particular input which we give as an image, then the convolutions, or this is a small filter of a particular size, right? It will that it is in the similar way as we used to do in the image processing or the signal processing, that this filter, this kernel will be moved over the entire image, and the particular features from that image which is related to this kernel will be taken as one feature map, right? So if I take 5 kernels, so it means all these 5 kernels will be moved on the image, and they will extract 5 prominent features and will make it as one image map or a feature map, right? I'll show you how. So this is one step. And then for the dimensionality reduction, subsampling is done with the pooling layer, and the size you can see goes on reducing. Okay, and at the end, after all the stack of the layers, this information is given to the fully connected network, where again it is the same architecture of neural networks, that every feature will be converted into one feature map. It will be connected further till it goes to the output. So this is the basic crux of the convolutional neural network. Now I'll show you one by one if I have time. So like convolution layer, this is the image, okay, and I have tried to make it very simplify as if I'm teaching in the classroom. So if those who are already know about it, they may find it childish, but those who participants, those who are doing it for the first time, they can be they can benefit from it. So suppose I have a kernel of 3 cross 3 as it is shown in the red box, right? As I told you, this kernel will be moved, will be strided from on the entire image, and these 3 cross 3 9 pixels will be replaced into 1 pixel. It is similar to as we are doing in the image processing or the signal processing. So you can see the kernel is placed over this and it is replaced by one value. Then it is moved to the other pixels, set of pixels, 3 cross 3, another value. Similarly, the next pixel and to the other, and so on. So this kernel, which is responsible for finding out a particular uh, feature, that may be an edge, that may be a color change, contrast change, whatsoever, we are moving this kernel on the entire image, and we are replacing the one set of image into one feature map, which is size. You can see now this size was 6 cross 6, 36, and we have reduced it into 4 cross 4 depending upon this size of the kernel. If I increase the size of this kernel, obviously the size of this output will decrease, right? If I reduce this size to 3 cross, this is 3 cross 3, I can make it 1 cross 1. We do not prefer even number of size of the kernel of 2 cross 2 or 4 cross 4. That is for the obvious reasons. So main thing is that each kernel, each filter which we are using will be responsible to give me one such feature map, right? And the spatial locational information is also not lost. So if I is here, it means corresponding to that feature, I will be here. If nose is here, corresponding nose will be there, right? So this is how the convolution layer works. Mathematically also, you can see image. This is an image where these numerical values are to the pixels. This is the filter or the kernel. Again, its pixel also have certain weight. It moves on entire image and gives you the output. Simple mathematics, convolutional, what we used to do in the image or the signal processing. So this is how the entire kernel will be passed on to this. The dot product between the weights and the pixels will be taken, and the net output you can see here for all the rows. So this goes on and you can see how it is moved on, right? So if you have a 32 cross 32 and you use a filter of 5 cross 5, and because the depth of the image is 3, that is RBG we are taking, so the size of the filter should also be 3, and this size of the kernel can be changed. So if I use this 5 cross 3 5 and you pass on to the all, right? If you mathematically, if you see, you will get that the weights are multiplied by the inputs and a bias, and those who are comfortable in the neural network, they can very well recognize that this mathematical equation is nothing but simply the neural network model equation, right? So the background of the deep neural networks or CNN is same as the neural network configuration, but how to use those to extract the features, that is only the difference. So you see 32 cross 32 image, 5 cross 5 cross 3 is the filter. It will convolve on all the, we call it at convolution because we are doing the dot matrix, right? So we are doing the convolution and it is convolved and slide over the, and we get one map of 28 cross 28 with depth 1. Similarly, so this was for the colors. You can see RBG. So I'm showing it as it is for the blue filter and the output is blue. Then we are using for the green filter and you're getting another output which is green. Then we are using for the red. So you see, so if I use 6 feature filters, right? So it means 6 kernels are moving over the entire image and we are getting the 6 feature maps. So this is how the convolution is done, and we are reducing the size, but the number of feature maps is increasing. Okay, so this is how the convolution goes. Now the size of the, there are certain hyperparameters. So the size of this convolution kernel which we are going to use determines the size of the output image. So if I'm using 3 cross 3, so it will move like 3 cross 3, right? And we will get an output of, depending upon how it is going, right? So we will get a 5 cross 5 output. And you can just see that when we are moving this kernel, we are taking next stride of one column. That next will be like this, the next stride will be like this. So that we call the stride, that how this kernel is moving. So I can move it one row, one column at a time, or I can move it two column also. So this is now two stride if you see. So the next stride is after two columns. So the size of the output will depend upon that what is the size of the kernel and how we are moving towards the stride. So same image, same kernel, but with one stride the output will be 5 cross 5, whereas the uh, with the stride 2 we will have the output as 3 cross 3. So it, and if I have the 3, then it won't suffice, right? So the output size can be very easily be determined by seeing that what is the size of the image, what is the size of the kernel, and what is the stride, right? So this is how the output images can be found. Now again, there is a practice of zero padding, that is the because when we are moving the kernel we are not able to access the information about the edges properly, right? The all the pixels which are on the periphery or the edges, they are not covered. So that is why we do the zero padding, that is extra row and extra column are added on the entire image, so that when we are moving this kernel the information about the edges is also covered. So there are other two types of paddings and all we can do. Okay. Now next comes then. Okay. So mathematically, if you see, it is the same which we used to do the convolution. The images are the input images are there, right? And we convolve with the kernel, that is the weights and the input features, and we get the output. It is same. The mathematical model is similar to what we did. Then comes the next, which is the non-linearity. So if you people know about the neural networks, we always prefer to go for the activation functions which are sigmoidal or tan hyperbolic, right? We have sigmoidal, tan hyperbolic, linear, but to combat the non-linearity, we go for tan hyperbolic or sigmoidal. But with the research and with the extensive empirical studies, it was seen that these sigmoidal and tan hyperbolic have the problem of vanishing gradient. That is, as the data set increases, the gradient almost becomes to zero. And we know that the neural network works on the principle of the stochastic gradient, right? So if the gradient becomes zero, so there will be no movement and there will be no learning. So that is why this problem, this challenge which we were facing with the sigmoidal and tan hyperbolic, it was overcome by use of the another type of activation function, which is the ReLU activation function, rectified linear unit. The diagram you can see, this is that mathematically below zero it is zero, and above zero it is rectified. So there will be no problem, it is totally linear, and there will be no problem of the vanishing gradient even if the number of data or the size is increased to a larger value. Okay, so this the mainly the activation function which we are using is the ReLU, or we are using the soft plus or the soft max at the last time, right? So the non-linearity sigmoidal kills the gradient, and ReLU is most important, is this one, right? So and we have other type of ReLUs also, leaky ReLUs, randomized leaky. Those who are into the research work, they can try with the different type of ReLUs, and they can see how their uh, the problem is being solved, or the application is being solved with the help of the different type of ReLUs. Okay, right. Now comes the pooling layer. As I was discussing, that the pooling layer is basically responsible to reduce the spatial size and reduce the amount of parameters. And above all, it is very beneficial for avoiding the overfitting, which is a very major problem in the neural networks, and where we are employing the back propagation. That usually we go for, and when the data increases, then this problem becomes very prominent, that is the overfitting. So we go for the pooling layer, right? So how does this pooling layer works is, now let us say that this feature vector, feature map has been received after convolution. So these values are the, say, the pixel intensity or any information. So now we, for the dimensionality reduction, we take a cluster of say 2 cross 2, right? So 2 cross 2 pixels are taken together, and this information is replaced by one information based on whether we are using the max pooling or whether using the average pooling. So as the name suggests, the max pooling means we will replace these 4 pixels by the maximum value of the pixels, that is the 400. Okay, so now you can see this value is replaced by 100 if we are taking for the max. Similarly, from this one it is 124, from this one it is 12, and from this one it is 45, right? And if we go for the average pooling, then we replace these 4 pixels by the average value, these by the average. So main thing, the information is also not lost, because if you are taking the maximum 100 value, it means जो बाकी values है वो इससे कम ही है, so it remains there. Okay, but dimensional reduction is there. So we had 4 cross 4, and now we have reduced it to the 2 cross 2. So this is how the dimension reduction takes place with the help of the pooling layer. Okay, so you can see that if we start with 224 cross 224, and we can downsample it to 112 cross 112, and then pooling to even 2 cross 2. So this is how the effect of the pooling comes. Then lastly, we come to the fully connected layers. So fully connected layers are nothing but the final step of the neural networks. That is, it is a regular neural network where, as the name suggests, it is fully connected means every layer, I'll show you, every layer is connected to the other layer, right? So if you see, this is a simple network of convolution neural network. So these were the input images, and we have the different set of the convolution max pool, then filter, convolution, max pool, and this goes on till, see here, number of filters. And then we have the fully connected layer where this output is connected to all the neurons, and then we get the output. So it is similar, but yes, again, the similar to neural network, but the activation function is used as the either softmax or redo. This is the prime difference, right? So if I show you this, so this is the image directly. No need to find out now the cake. What is the size of the car? What is the dimension? What is the color? What is the size of the headlight or the car? This is directly given to the CNN. And you see, after first layer of convolution, you are getting such type of information. After second, you are getting this. After third, so this goes on till you get to the fully connected, which will decide that this is a car or a truck or an aeroplane or a ship or a horse. So this is how the uh, it goes on, right? So I won't go for this. And there are other parameters which I will think will be go beyond the scope because a lot of other sessions are to be taken. But these are certain parameters which are handled when we do the convolutional neural network. Overfitting, as I told you, that this is a very common problem which has to be handled, and it is very nicely handled with the deep neural networks. Then regularization and dropouts, and so we have to tune certain hyperparameters. I'm not going into these details, right? So now certain there are two ways to go for the research. One way is to design your own convolution neural network. That is, how many convolution layers, how many max pooling, what ReLU factor, how many kernels, how many depth. So one way is to design your own architecture, which comes with a very much of experience and lot of research, right? The other way is we have certain pre-trained network CNNs, which are LXNet. There is a one challenge going on since 1998. After every 2 years, it is floated, right? And the researchers or the scientists, they come up with the CNN for particular applications, maybe for like the classification or for prediction or categorization, clustering, and the winner of that problem, that floated problem, is given that the name. So LXNet was the winner of 2012, VGGNet was 2014 and 15, and every network which is the pre-trained model has its own predefined architecture. So if you see this, LXNet has a predefined architecture. You give the input data, it has first convolution and max pool, second convolution, max pool, third convolution, fourth, fifth, so on. If you see inception, two convolution, one max pool, two convolution, one max pool, then inception, 3AB. So what I want to say is that these pre-trained classifiers are available and they are trained very efficiently, and you can use them for your own research work. So they are freely available on the GitHub, right? You can use them for your application, for your problem, and you can work on it. So every network has its own architecture, has its own feature, and has its own application. So if you want to work for object recognition, go for LXNet, right? If you work for image classification, you can go for the you can go for the Google Net, right? Like then you have VGG Net. Now you see so much of the LXNet was this architecture, and as the technology advancement, VGG has 16 layers, right? And three convolution, then pooling, and then fully connected and softmax. So like one of my research, if you want to have something on medical image processing, you can search out my papers, and we have done work on this CNN on inception V3 for image classification. So VGGNet is for again image classification. It has its own architecture, its own features, right? So all, and there the best part is that they are available free of cost on the GitHub. So similarly for ResNet face recognition, and for inception V3, like our work is on inception V3, which is 48 layers, and it reduces the overfitting problem and can be used for the image classification. ResNet can be for the voice recognition. So every these pre-trained networks, they have, you can just see the complexity. Obviously, as technology advances and major problems they counteract, then the complexity increases and efficiency also increases, right? So uh, this is with this I would like to conclude. I have tried to add on some information on the CNN as related to the deep learning, taking for granted that the participants have certain idea about the neural networks, right? So convolution neural networks, these are the links which I have provided. If all, if the participants, those who are working on this, and uh, those who are interested in finding out the open sources, so these are the sources where you can see the classification demos or deep learning demos, right? Handwriting classification, video classifications, these are the database which are available on the net. And there are so many databases also which are available. These are the platforms. You can work on the deep learning platform with R and Python, which are open sources. MATLAB has also the platform, but that is paid, and you need to purchase the toolboxes of the MATLAB for the convolution neural networks. The libraries are also available. Python has developed this library. TensorFlow has open source libraries, right? So with Python, you can access the GPUs, facilities of GPUs, because simple computer will not be sufficient to process so much of data. Simple laptop will also not be sufficient. So you need to have GPU and TPUs, so which are not available. So go for the Python or TensorFlow, which makes you use the GPU while sitting on your computer or while sitting on your uh, mobile itself, right? So these are certain libraries and platforms which you can work. So deep learning is a powerful and generalized principal network platform which is very crucial and has become very much of importance in every application. You think of any application, whether it is internet or cloud, speech recognition, language processing, sentiment, anything. You talk about the medicine and biology, diabetic grading. I told you my one of my work is on diabetic retinopathy grading only. Other work is on MRI classification, and in all we have used the deep learning. Then media and entertainment, right? Security, face detection, video surveillance, satellite, and now you all know about the automatic vehicles also, right? So all these things are making use of the deep learning everywhere. So if you are thinking of getting into the research work related to deep learning, you can just think of any of these applications and you can work on it. So thank you so very much, and I'm open to any question or any query which the participants may be having.